Welcome back. It is 6:40 on this Tuesday morning, and we have a treat for you this morning. NASA is about to launch a new satellite, and this isn't just an upgrade. This is a total game changer for important information about our Earth. It's called NISAR, and it is the first joint space mission between the U.S. and India. Joining us now is Dr. Karen St. Germain, NASA Director of Earth Science from the NASA Goddard Space Flight Center in Maryland. Good morning to you.
Good morning. It's great to be with you.
So glad to have you here. So this is something that, forgive the pun, is going to be stellar for us here on Earth. And we want to know why. Tell us about this mission.
Well, we are super excited to be launching NISAR next week. It will be the most sophisticated radar NASA has ever launched. With its almost 40-foot antenna, it will be able to see changes in the Earth's surface of about a half an inch over areas the size of half a tennis court. And these small changes can make a really big difference in the lives of people.
And so first, let's tap into this sophistication. I hear that there is a very large portion of this that's kind of shaped like a mitt, like a baseball mitt. Can you tell us about that?
Yeah, that's the deployable antenna. And what that does is it transmits pulses of energy down to the Earth. They bounce off the Earth and they come back. And that antenna also catches those return signals. And it's that gives us the information about how the Earth's surface is changing.
And I think it is so impressive because the satellite is going to be so far away, but it is monitoring these minute details here on the ground because of the strength of that radar, the eyes that you have there. And one of the things that we have a lot of here in the ocean state is shorelines. And I know this is going to be monitoring some of the changes down to the centimeter there. Talk about what this could mean for concerns, particularly in our area.
Well, it's a great point. So in Rhode Island, the shorelines are constantly changing, and there are lots of communities and businesses along those shorelines. So when we can see these changes from space, we can inform decisions like building out infrastructure or navigating along those shorelines. This kind of information can help businesses prosper and keep communities safe.
And it's not a little bit of information. This is a massive amount of data that you guys are going to be collecting. Talk about how much this is and why we have the need for so much of this to monitor and influence change.
Well, it's true. NISAR will produce more data than any other mission we've ever launched. And that's because we are going to be looking at changes around the globe. When you think about the kind of information that measuring small changes can give you, this can let us know we'll be able to see the bulges before a volcano erupts, or those early indicators of shifts that may tell us an earthquake is happening. We can also detect destabilization that is a precursor to landslides. And even changes in the glaciers and snowpack in the mountains that provide the water that communities downstream, ranches, farms, and communities need. So there's a lot of information, but I think the key thing to know is all of this information is going to be openly available and will transform that raw data, the radar data, into that actionable information that communities can actually use.
And I think it's so important that you use the word actionable right there. You touched on a lot of things that really impact natural disasters that can impact hundreds of thousands of people. We've seen earthquakes recently in the recent history. We've seen volcanoes erupting out in Hawaii. Can you talk to us a little bit about how this type of comprehensive data has previously influence some of the ways that communities prepare for these natural disasters?
Yeah, When we can make these measurements from space, they can not only tell us the current state of what's happening, but also inform the models that we develop that give us a predictive capability. Everybody's used to this in weather prediction. Well, we can start to do the same thing with earthquakes and landslides and coastal flooding and that sort of thing. And the better we can get at predicting, the more uh, the more lead time communities have to prepare. And then also, after such an event, the more information we can provide about the impact of the event to communities, the better the community can respond afterwards and recover from these kinds of events.